Okay, so moving on to the second half of Unit 4. This one deals with exponents. So if you want to go ahead and open up your Google form, your notes section, and the homework. Okay, so in the notes section you are going to need the new set of notes. So download or print out, whichever one you use. This is the one we're going to be using for the next couple of weeks. Alright, so we're going to kind of see what's going on with these patterns just to review. These are Algebra 1 topics, but we'll go through all the properties just to review all of them. Alright, so in the new packet, this is the second half of the factoring exponents unit. So here we're going to use the properties of exponents, which you learned in Algebra 1, but now we're going to apply them to rational exponents, which is the part that's Algebra 2. So again, this A11B is simplifying using laws of exponents. The 2A gets into Algebra 2, and that's the part where we have to rewrite them in radical form and then solve them. All right, so again, we're going to review the properties of exponents and extend them to do rational exponents. Alright, so what we're going to do here is write these out and see what's happening once I write them out and then combine them into exponential form. So here, notice this was 3 squared. So 3 squared means I have 2 of them, times 3 to the 5th. 3 to the 5th means I have 1, 2, 3, 4, 5. So combining them all together, I get 3 to the 7th over here. So that's where 7 comes from. Okay, so if we do the same thing for the 2's, 2 to the 4th means I have 4 2's. And then 2 to the 6th means I have 6 of them. 1, 2, 3, 4, 5, 6. And then combining them all together, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 2's. Okay, so we're trying to figure out what's the rule for these properties of exponents. So here we have 1, 5. So we have just 1, 5 here. And technically there's an exponent of 1 there. We just don't have to write it when there's just one of them. And then for this one we have 3 5's. So altogether 1 and 3 make 4 5's. Alright, so those are numeric expressions. I can do the same thing with algebraic. So here I have 5 b's. 1, 2, 3, 4, 5. And then I have 8. 1, 2, 3, 4, 5, 6, 7, 8. So if I combine them all together, I get 5, 6, 7, 8, 9, 10, 11, 12, 13 b's. So what I want you to do is figure out the pattern from one to the other. Okay, so then what we got to ask ourselves is looking at the original expression and then going over there to our exponential form, what do you notice when we combine them? So right here, 3 squared and 3 to the 5th make 3 to the 7th. 2 to the 4th and 2 to the 6th makes 2 to the 10th. 5 to the 1st and 5 to the 5 cubed makes 5 to the 4th. B to the 5th and B to the 8th makes B to the 13th. So what's happening with the exponents? When the bases are the same and I can combine them, we are adding the exponents together. So if you are multiplying two exponentials with the same base, they have to be the same base. So 3 and 3 combine. The base stays the same. You actually don't multiply the base part. That part stays the same. What you do is you add the exponents. Add the exponents, add, and add. So when multiplying with the same base, you add the exponents together. So on your Google form for that one, That's all you're going to go type in is right here. Looking at the table, describe your relationship. When we multiply with the same base, we add the exponents together. Okay, so that's what we're going to be doing on here. Alright, so that property says if I have two exponential expressions with the same base, then I add those exponents together. The base has to be the same in order for you to combine them. So here for the first one, they both have a base of 2. And then I'm going to add these exponents together. I don't multiply the 2's. The base stays 2, but I add the 6 and the 8 and get 14. Don't give me that number. I don't care what that number is. The fact that I'm just adding them, it's a really, really big number. So we're just going to write them in exponential form. Okay, so for part B, base, 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 they're all the same base. They all have -7 as the base. So then we're going to add 3. There's a 1 here and a 5. 3 plus 1 plus 5. 4 plus 5 is 9. And that's all we do. We're not going to actually figure it out. Alright, so likewise here on the M, there's a 1 there. They're all M, so we can combine all of them by adding these exponents together. So 5 plus 1 is 6, plus another 6 is 12. And then here's where it starts getting a little bit more complicated because we have multiple numbers and multiple variables. So we want to combine the ones that are the same. So we want to combine all the numbers that are the same. They don't have variables. So they're not attached. The numbers and the coefficients and the variables aren't attached together. So I'm just going to regroup these. So I'm going to put all the coefficients together and multiply them. I'm going to put all the a's together. A to the 5th, a cubed, and that's all the a's. And then put all the b's together. B squared and b squared. Because I'm multiplying to begin with, everything is a multiplication sign. So I can rearrange it and it's the same thing. So then I just combine them together. The numbers are like regular numbers, so I'm going to multiply these. 2 times 3 is 6, times 5 is 30. And then I combine with the same base, so I combine my a's together by adding these two. So 5 plus 3 is 8. And I combine my b's by adding these two together. 2 plus 2 is 4. Technically you can write all of this out. I mean, good luck when they start getting really big numbers. So if you wanted to, you could write 2 and 5 a's, A, 3 and 3 a's, and 2 b's, and 5 with 2 b's. And then you can combine them all together. 2, 3, and 5 is 30. Count up all your a's together. There's going to be 8 of them. Count up all your b's. There's going to be 4. You can do that right now, and it's fine. But very, very soon, these are going to be fractions, like 1/2. How do you write half a b? At that point, I mean, you really can't write it out. You have to use the properties in order to simplify them. Okay, so the first 3 properties are the important ones, so I do want to spend some time on those. So let's go to the next property. And the other ones go by really quickly, but these are the 3 important ones. So the next one is the product property, where I have an exponential inside, and I'm raising that to an exponent. So this is a power to a power. So 5 squared means I have 5 squared 3 times. Well, what does 5 squared mean? 5 squared means 5 times 5. So I'm going to have that 3 times. So then counting them up, I have 6 5s altogether. Okay, so this one, I'm going to have 8 cubed 4 times. So I'm going to have 8 cubed 4 times. Oh man, this is going to be a lot of 8s. So for the first group, 1, 2, 3. Second group, 1, 2, 3. I hope you get the pattern by now. There are how many 8s total? 3, 6, 9, 12. And then, alright, and then the last one, we have x to the 5th 2 times. So x to the 5th, x to the 5th. Means I have 5 x's here and 5 here, for a total of 5 10x's. So again, this time we're comparing the exponents again from columns 1 and 3. So notice here the exponents were 2 and 3 for the first one, 2 and 3, and when we combine them we got 6, 3 and 4 got 12, 5 and 2 and got 10. So what's the rule when we're multiplying an exponent to an exponent, a power to a power? When you raise an exponent to another exponent, you end up multiplying those exponents together. So we're going to go type in multiply into the Google form, and that's what we're going to go do here. So again, when we raise a power to a power, it's the same base, so it has to be the same base. Then we multiply those exponents together. So again, we're actually not going to solve these out or simplify these or get the answer. We're just going to combine them together. Okay, so for the first ones, so we have 7 to the 4th to the 9th. Again, this is one you're definitely not going to want to write out. So the base stays 7, and we multiply these exponents together. So 4 times 9 is 36. Here k is the base, so that stays, and we multiply 3 and 13, and that's 39. And here w is the base, so that stays, and we multiply 10 and 20 to get 200. So if it's just a single variable, it's fairly easy to figure out what's happening. When there are multivariable ones with numbers, this is when it gets a little tricky. So here, for the y's, we're basically applying the 3, the cubed on the outside, to all of them. So I'm going to kind of split this up. I'm going to do 2 here, x to the 5th, y cubed. Those are all the variables and coefficients inside, and each one of those gets a cube. So cube, cube, cube. So we're going to multiply these because it's a power to a power. So multiply y, we get 3 times 3 is 9. Multiply the x's, 3 times 5 is 15. And then here we actually cube the 2. So 2 cubed is 2 times 2 times 2, which is 8. Okay, so this is when it starts getting a little tricky. When you have multivariables and multi-coefficients, multi-numbers, you have to make sure you apply it to each one. Alright, so that's the power rule. So the product rule is when you add the exponents. The power rule is when you multiply. And then the last important one, the last main one, is when you divide. So here I'm dividing 3 to the 5th, so I have 5 3's by 3 squared, so I have 2 3's. So when I reduce them, these cancel each other out, so I only have 3 left over. So that's where the cube comes from. So for the 100, if I have 3 hundreds, 1, 2, 3, and I divide it by 100, then these cancel, and I'm left with 200. So 100 squared is what I'm left with. Oh, yikes. Okay, So I'm going to write 15Ks out here. 10, 11, 12, 13, 14, 15. This is at this point, this is where you kind of want to know the property, but you don't want to have to keep writing these out. And then 11, 5, 6, 7, 8, 10, 11. And if I cancel them out, these cancel. So I'm left with 4 of them altogether. Okay, so now comparing the exponents, look at the columns 1 and 3 and compare the exponents. So notice the first 2 exponents were 3 and 5, and I got, 5 and 2, 5 and 2, and I got a 3. This was a 3 and a 1. If nothing's there, it's a 1. And I got a 2. And 15 and 11. And I get 4. So what's the operation? 15 and 11. What operation would go there to get 4? 3 and 1. And then 5 and 2. I would have to subtract these in order to get that missing exponent. Okay, so here the property is, when we're dividing with the same base, the base has to be the same in order for you to do this. You subtract the exponents on those like bases. Okay, if they're different bases, you can't do this. They have to be the same base. Okay, so the general rule is if I'm dividing with the same base, so here my bases are A, we subtract those exponents. So notice we don't do anything to the base. The base part stays the same. A stays. All we do is subtract those exponents. So for 9A here, the 16s are going to stay. All we do is subtract 7 minus 3 and get 4. Okay, we're not going to actually solve that. Again, it's a big number. We're just going to leave that alone. So for B, we combine the same bases. They're both W's. So W. And then we subtract 25 minus 10 makes 15. So 15 there. C is actually a multi-step one because I have multiple bases. It's not just one on the top, one on the bottom. So I have to combine in the numerator first. Combine that into one base. So remembering the product property, if I have 2 exponentials with the same base, then I add the exponents together. So I'm going to add 3 and 7 and get 10, and then combine that with 4 to the 5th. Okay, so just like we did for A and B, now the bases are the same, 4s, and I subtract 10 minus 5. 10 minus 5, subtracting, is just 5. And if I ask for work, I mean, this is work right here. You just tell me plus, adding, subtracting, whatever you're doing. That's considered work. Okay, so now over here for part D, we actually have multivariable ones. So again, we have to combine the ones that are the same base. So we're going to combine the D's together. We're going to combine the C's together. And we're going to combine the numbers together. So again, the numbers are not attached to the variables. They're each their own little piece. So when I combine the variables, let's do the variables first because that's using the rule. C to the 6 divided by C squared is 6 minus 2. Makes 4. And then when I combine D's, we do 9 minus 4. And that makes 5. Now the number part is normal. This part, we don't use the product rule or the quotient rule because these are not exponents. These you just do what it says. 12 divided by 4 is 3. The rules only work for exponents. If it's not an exponent, you do what it says. Multiply or divide or add or subtract. Okay, so those are the 3 main ones. The next section is going to be The other ones that you're going to need to know, but they don't really have, I mean, the name's not as important. These three, it is important that you know the name.